Any questions out of 2.7 first? Would you like me to just work out a couple of those, or? Yeah, because I think we actually did 2.6 and 2.8. Sorry about that. Well, we can look at questions that are 2.6, 2.7, or 2.8 if we need to. So 2.6 was those piecewise defined functions. So did we have any questions on 2.6 to look at? Let's see. Any of those that you'd like me to work through?
Different brackets or maybe the same thing?
I do what now?
On 2.6,
Uh-huh.
like on number 4.
Yep, let me find a quick page here. Yeah, number 4, those are greatest integer, and we covered those not last week, but the week before. And what those are is those are a special kind of function, and when we go to graph them, the graph is the greatest integer function. And remember, your graphs are in the back cover of your textbook, and the greatest integer looks like a case of stairs. Would you like me to look at maybe one of those? Okay, yeah, I can look at one of those. Do you have a preference, or do you just want me to pick one? Or do what now?
Like I don't have
Okay, yeah, I'll just look at question 5 then. Out of 2.6. Any others out of 2.6 to look at? You need to work on any of the graphing ones.
3.
Sure, we can look at question 3 as well. In question 3, we have to come up with a rule for that graph. Any others? I think the week before we actually covered 2.7. So do we have any questions now out of 2.7 to look at? Any of those? I think we covered a lot of those last class period as well when we reviewed it. Then what about, I know last time we also finished 2.8. Do we have any questions on the homework out of 2.8? Number 2? Sure. All right. Any others? Those hopefully make sense. Okay, the 2 and 3 are very similar. If you can do one of them, you can do the other one. So we'll go ahead now and look at 2.6, and we'll start now with question number 3. And 2.6 was the greatest integer functions and also piecewise defined functions. And for question 3, what we need to do is we need to come up with the rule for our function and also give the domain and the range. So I'll quickly graph these here. Okay, so here is our graph. Now what we want to do is we want to find the function that this graph came from. And we've got 2 levels. And when we look at these, we need to remember that strictly less than, strictly greater than, those are represented by an open circle. Greater than or equal to, less than or equal to, those are represented by a closed circle. Now we look first at where it transitions. So where does it transition? Where does it jump from one level to the other? And we label it on the x-axis. So it looks like it transitions right here at 2, doesn't it? If I look at my picture here, right? That's where it, because see, it stays at this 3, and then it goes up at -2 to that 4. So it looks like it transitions at -2. And we read them from left to right. So the first part is going to be if x is less than a -2, because we're reading it from left to right. So everything less than -2 falls under this row. Our next row is going to be if x is, we've got our closed circle, greater than or equal to a -2. And what are the functions that we're working with? Well, if we read our first one, this is a constant function, and it looks like it's a constant function at 3. And the other one is a constant function, but if we count, looking at our picture, it looks like it's a constant function at 4, doesn't it? So is everyone okay with how I got that? So we switch from one row to the other at -2, one function to the other. And so our first one is going to be for values of x that are less than -2, because the open circle. Our second row is for values of x that are greater than or equal to a -2, because it has the closed circle. Our first one is a constant function at 3, and the other one is a constant function at 4. Finally, we need to get our domain and our range. Remember what the domain is. The domain is your x values, and that's left and right. Okay, this graph can go left and right, so my domain would be negative to positive infinity, and my range is a little bit different. My range is either at 3 or at 4. So your range would be 3 or 4 there. So does it make sense now how I was able to determine what the graph was? So we figured out first where that transition was on the x-axis. So we transitioned at that -2. And we made sure we worked from left to right when we write these up. So from left to right, it's less than -2. And then the other side, it's greater than or equal to a -2. These were constant functions. And then we also got our domain and our range. Now, question 5, we need to graph the greatest integer function. And these are not absolute value bars. These are greatest integer bars. And we want to graph these. So we first need to figure out what our graph should look like. So we go to the back cover of our textbook, and we are working with the greatest integer. So the greatest integer graph looks like a case of stairs. We always start with a closed circle. So we'll do a quick sketch over to the side, and then we'll draw a better picture with our translations below. So this is just kind of a sketch of what it should look like, and we're going to have to move it a bit. So that's our case of stairs. Now what about that -1? Remember that -1 is located inside the operation. Numbers on the end move it up and down. Numbers inside move it left and right. The way I remember, since it's inside, is it's opposite of what you think it would do. So you would think it would move it back to the left, but it actually moves it to the right. Okay, so that's going to move that graph 1 unit to the right. There's no number in front, so we can put a 1 there. We don't have to, but if it's helpful, we can put that there. So where are we going to start at? So first thing we want to do is we want to start at 1 unit forward, up 0 units, right? Because we're moving it forward 1 unit. So we're going to start right here with a nice closed circle at 1, 0. And then what are we going to use? Kind of like our slope here, the number in front. And that means we go up 1 and over 1. So up 1, over 1, make a dot. Up 1, over 1, make a dot. Okay, then we need some in the opposite direction as well. So we go down 1, back 1, down 1, back 1. And then we just fill them in with our open circles below. Okay, so there's what your graph should look like. So what did we do here? All we did was we simply moved that graph what? We moved that graph forward to the right 1 unit. So it just got slid over, and that's all that happened. We didn't change the size at all. All we did there was slide it forward. And now we'll look at 2.8. We'll look at question number 2. And question number 2 is a 2-part question. And so what we need to look at is our compositions. And we have to look at both sides of the composition. So question number 2, you're given these 2 functions. So for question number 2, out of 2.8, you're given f of x equals x cubed plus 8, and also g of x equals the cube root of x minus 8. So these are our 2 functions. And we need to do both sides. We need to do both compositions. So we need to check f composed with g of x. And we also need to check g composed with f of x. And we want to see if these come out to be x or some other value. This is a yes or no question. We just need to see if they are the same, if they equal x or if they do not. So how composition works is you plug one function inside of the other one. So this is f composed with g. I just wrote out the version that's more useful. And so what we do is we do the innermost parentheses first, and that's g of x. And g of x is the cube root of x minus 8. So I replace g of x with what it is. And then what do I do from there? Then I come up and I get my f of x, and I replace that x with a set of parentheses. And then inside this parentheses comes down to be that cube root of x minus 8. And what happens when we cube a cube root? Well, when we square root, the square and the square root go away. So the same process works with the cube. When we cube a cube root, the cube goes away. So then we're left with x minus 8 plus 8, and that comes out to be what? That comes out to be x. So that part would be a yes. It's just asking if these equal x or not. So this side would be yes. Now we need to check the other. So now we're going to work on the other side. And g of f of x. Well, f of x would go on the inside. And that's x cubed plus 8. And now we write our g function with parentheses where the x was. And then we bring down our parentheses. So that's going to be x cubed plus 8. And what's going to happen with the 8 and the negative 8? Well, they can cancel out. So that then leaves you with x cubed underneath the cube root. And the cube root of x cubed comes out to be x. So that one would be a yes as well. So what we needed to do is to work out both sides to see if they come out to be x or if they come out to be something else. Does that make sense on that one now? Just do your compositions and check and see. And that one came out to be yes, but number 3 will not, because number 3 is not going to work out the same way. You do the same process, but it's going to give you something that's not x. It'll be something else. Okay, did we have any others to look at?
Can do 8.
Sure, we can look at 8 as well. Okay, now, on question 8, we're trying to find the domain of this division. Now, what is the domain? Well, the domain, again, is values of x. And what can we not have in our domain? I know it's been a while since we looked at those, but that was in 1.5. And remember, for the domain, you can't have division by 0, right? Okay, so we cannot have division by 0. So we're going to look at this division, and we're going to find what number or numbers do not work. So we've got f of x equals 5 over x minus 3. And let's go ahead and get the domain of this one. And so what number is not going to work here? Not in the domain. The number that's not in the domain on that particular piece is 3, right? Because 3 would give you division by 0. What about g of x? Is there anything to worry about with it so far? No, because there's no fraction, so there's nothing to worry about. Now we need to look at f over g of x. So that would be f of x in the numerator, g of x in the denominator. And now since we put that g of x in the denominator, we can't have division by 0 here either. So in that piece, what's not going to work? Well, in that piece, what's not in the domain? Does anyone know just by looking at it? What number is not in the domain here? 6. Okay, because 6 would give you division by 0, wouldn't it? Okay, so what numbers are not going to be allowed? 3 and 6. Because 3 gives you division by 0 here, right, in the original fraction of f of x, and the 6 gives you division by 0 on this division part here. So how do we write our answer? Well, our domain would be negative infinity to 3, u for union, 3 to 6, union 6 to infinity. So there would be your domain for that. So does that kind of answer those questions now? So that one we didn't have to actually work it out. All we needed to figure out and determine was what numbers can we not have. And what numbers will not work. That's going to be 3 and 6. And how do we write it? Well, we split it up into our 3 parts. Okay, so does that take care of those things? Okay, so what we're going to be working on this class period and also next class period is we're going to be finishing up the course and we're going to be looking at some new material that's on your final. we still need to cover logarithms, and we still need to cover systems of equations. So we'll cover systems of equations, which is, I think, the easier part, quickly today. And then if we have time, we'll look at exponentials and logarithms next class period. So we're going to look quickly at systems of equations. This is actually in chapter 4. I'm not giving you homework over it, but there'll be several questions on your take-home final and on your final exam that are solving systems of equations. Now, what a system is a system has two equations and two variables. And we're going to find out where their lines, where these lines actually cross. So we're going to get ordered pairs. You could have this 3 by 3 or 4 by 4, but we're only going to focus on 2 by 2. So two variables, two equations. And you can either solve them by substitution or you can solve them by elimination. We're going to learn how to solve these by elimination, because I think it's the more preferred way of doing these. I'll give you an easy example, and then we'll look at some more difficult ones. And then we'll look at the ones on our practice final as well. Okay, so here's going to be our system. And I'll go ahead and make up the answer for this one. That's going to be our answer. You won't have that. You'll have to find it. But I'm just making them up as we go, trying to come up with some easier ones to work with. So we'll come up with our systems here. So 4 minus 9 gives you a minus 5 for our first one. And the second one is a 28. So this is an example of a system of equations. So we've got two variables and we've got two equations. Now what we want to do is we want to work with these systems, these equations, and want to be able to rewrite them so we can eliminate one of the variables. So we want to be able to add these together and get rid of one of the variables. So let's see how we can do that. Well, when I look at these, both of these equations have that 4x in it, right? And if I were to just add down, well, that would give you 8x. And we don't want that. We want to make one of the variables go away. So what we can do is we can take our first equation and we can change the sign. So we can distribute through a negative. So we're going to take our first equation and we're going to distribute a negative through. And that switches all of your signs. And negative there makes it a positive 5 as well. The second equation is going to stay the same. Now, why did I do that? Well, I want to eliminate one of the variables. And when we add these together, now when we add down, look at what happens to the 4x. Originally, they were both positive, so that would give you an 8. That didn't work for us. But since I distributed that negative through and changed everything, now if I add them down, what's going to happen? Well, if I add them down now, the x's will cancel out, won't they? Right? Because you got a positive 4 and a negative 4. And that's what you want. You want to eliminate one of the variables. So we're going to go ahead and add these down, and those are going to cancel. And then we have 3 and 8. That makes it an 11y. And then we have 28 and 5, that makes it 33. And now we have one variable left. We can divide by that 11, and now we've got half of it. So now we have y equals 3. We need to get both components. So once we have one, we can either eliminate for the other number, or we can just plug it back in and use back substitution. I'm going to use substitution because I think when you substitute it back, it's easier than trying to eliminate twice. So we have our 3. Okay, y equals 3. So we're going to take this 3 and we're going to plug it back in. Does not matter which equation you plug it into. Plug it into the first one, you can plug it into the second one. Does not matter at all. I'm just going to go ahead and plug it into the second equation. And when I plug that in, I have 4x plus 8 times 3, because y is 3 now. That equals 28. So that is then 4 plus 24 equals our 28. Move that 24 over. That leaves you then with 4x equals 4. Divide by your 4, and now we've got our second component, which is x equals 1. Okay, how do we write our answer? We write our answer as an ordered pair, and as an ordered pair, this would be 1, 3. And systems are pretty easy to work with. They take a little bit of time with the algebra, and it's easy to make a sign error, but really they're not that complicated. Try another one of these. They're all a little bit different, but you use the same process here. Okay, so how about 3x plus 5y? And the second equation, how about is a minus 6x plus 4y? And how about we make our answer to be 2, negative 3. Okay, so let's see what we would get here. First one's going to be a negative 9. And again, you won't have that answer. You're going to have to solve for it. I'm just creating ones that have nice numbers for us to work with. So I created the answer first, and I'll build my equations from that. Okay, that one's going to be a minus 18. Okay, so everyone all right with what we've got here? Now, when we look at this type of equation, we need to pick a variable that's going to be the easiest one for us to work with. And when I look at this, we could either eliminate for the x or we can eliminate for the y. Now, one variable is going to be a lot easier to eliminate than the other. We think about clearing fractions and we look at them as least common denominators. Least common denominator of 3 and 6 would be 6, right? Because 6 goes into 3 and 6 goes into itself. Now, what about 4 and 5? Well, 4 and 5 would be a least common denominator of 20. So which one do you think is going to be easier? 6 is smaller, right? It's going to be a little bit easier. Now, what our goal is to make sure if we eliminate for the x, these two numbers are the same. Opposite in signs, though, so they cancel out. So we want the same number, just opposites in signs. Well, how can we make the first one be a 6? It's got a 3, so let's distribute a 2 through. We don't need to change the sign because that's going to give me a positive 6, and that positive 6 would cancel out, right, with the negative 6, and that's what we want. So go ahead now and distribute that 2 through. And if we distribute that 2 through, we get 6x plus 10y. And negative 9 times 2, watch your signs, that's a negative 18. We keep the bottom row the same, so it does not change at all. And now we can add down. So I kept you want to try to keep one row the same. Now in some cases you won't be able to. As we make them more difficult, you may have to do it to both rows. But in this case, multiply it by 2, that gives that 6. Now when we add down the second one, what happens to my 6's here? Okay, when we add down those, they go away, don't they? So 10 plus 4 makes it 14y. And then we've got an 18 and another 18, both being negative, makes it a minus 36. We divide by our 14, and that leaves us then with our value of y. And these should come out to be, make sure I didn't make a mistake somewhere. Okay, so make sure I didn't make a mistake. Okay, let me double check my answers here. Make sure I didn't make a mistake when I multiplied these through. Okay, that one's negative 9. Oh, I think I made a mistake on that one. Okay, so 6 times negative 2. Okay. Let me make sure I got that. Might have changed that to a different number there. Okay, so make sure I got the right answers here. I just made these up as I went along. Hopefully I added them together right. I think I missed my signs here. That should be now. Let me just make sure we don't have a mistake here. Negative and negative will make that positive. Sorry about that. I must have just copied something down wrong here. So that's a negative 12. Okay, so we have minus 12 plus. Let me just make sure we have this right because I see the mistake. I just want to make sure we make another mistake. Make that 0. Sorry about that. Instead of a negative 18, make that a 0. My mistake there. No wonder it wouldn't work. Okay, and when we add it down, that gives you a negative 18. I just copied it down wrong when I was making the problem up. So that's going to be a negative 18. Okay, and I don't see any other mistakes here. Let's make sure I made it right. So I don't think I made any others. Okay, so let me plug the numbers in to make sure. Because these should come out to be nice whole numbers, not fractions. It should come out to be 2, negative 3. So let's make sure I didn't make any mistake here. Hope I didn't just copy something down wrong. Okay, so that equation's right. Oh, sorry about that. Shouldn't be 0. Sorry about that. I added wrong again. Minus 24. That was my mistake. I just wasn't careful when I made that up. So minus 24. Sorry about that. And then that will now add up to give you that 42. And so that's going to give you that minus 42 over that 14 there. And minus 42 over 14, that gives us what we needed, which was that minus 3. Sorry about that. When I made it up, I just plugged the number in the wrong place. So now that we have that minus 3 as one of our answers, that's our y value. We can plug it back in. It does not matter which equation we plug it into. So we're just going to plug it back into that second equation. And that is then a minus 6x plus 4 times a negative 3 equals that negative 24. So that's then a minus 6x minus 12 equals a minus 24. Add your 12 over, and that leaves you then with a minus 6x equals a minus 6, or sorry, minus 12 there. Got ahead of myself. Divide by that negative 6. Negative over negative makes it a positive. And so now x is 2. So what is my answer as an ordered pair? 2, comma, negative 3. Sorry about that mistake there. Just wasn't careful when I made it up to begin with. Just mentally added wrong. But that's going to come out to be 2, negative 3. Let's do one more of these, and then we'll look at that practice final, and we'll work those questions out as well. So let's try another one. And again, we're just going to solve this system. We'll have, how about 4, -5 for our answer. Okay, make sure I come up with the right equal sign here. Okay, so 8 times 4, it's 32. And that comes out to be a -3. So that one should be a -3. And the next one will be equal to 1 times 4 plus -69. So that's what we've got here to work with. You know, when we look at this, we need to figure out which variable we want to eliminate. I would kind of avoid the x. Why would I avoid the x? Well, we've got an 8 and a 9. And the least common denominator of 8 and 9 is 72. And so we would have to get 72. And that's a larger number. But what about the y's here? Well, the y is going to be much easier because 7 times what gives you 21? Well, 7 times 3 gives you 21, right? Now, when we multiply and work with these, we need to make sure that the numbers are the same, but one of them is positive, one of them is negative. So when we look at this, this is a positive 7 here. The other one's a positive 21. So we need this one to be a negative. So let's multiply the top equation by a -3. That way we get a -21. And then when we add down, then the y's will cancel. So distributing through, we have -3 times 8, that's a -24x. -3 times a positive 7, that's a -21y. -3 times a -3 is a positive 9. Second row, we're going to keep it the same. So that's 9x plus 21y equals that -69. And now what's going to happen if I add down? Well, if I add down in this case, the y's cancel out, don't they? So that's going to make the x left over. So what do we have? We have a -24 plus 9. That makes it a -15x. And then we have a 9 minus that 69. A 9 minus that 69 should leave you with a -60. We'll divide by our -15. And negative over negative makes it a positive. And that's going to come out to be a +4, isn't it? What do we do with that +4? We have the x value already. We need to get the y value. So take it, plug it back into one of the equations. Again, it doesn't matter which one you plug it into. So I'm just going to go ahead and plug it in the second one. And that leaves you then with 9 times 4 plus 21y equals that -69. 9 times 4 is that 36. We're going to go ahead and subtract off that 36 from each side. They go together to make it a -105, it looks like, equals 21y. We'll divide by our 21. And positive down below, negative on the top, makes it stay negative. So that means my y value is going to now be, it looks like, a -5, isn't it? So 105 divided by 21 should come out to be a -5, and it does. What then is my final answer? as an ordered pair? Well, easy enough. That's 4, -5. So pretty simple on these. Now let's look at some of these from our practice exam. So we've seen several examples so far. Now we'll work these on your practice exam. And if you look in this packet, you've got the practice exam, and you're going to notice that it's very, very similar to the take-home one. And after the practice exam, if you look here, you've got the worked out answer key. So I worked out all of these questions so you can see step by step how I did them. The practice one has 35 questions, or is it 40? I think it may be 40. Yep. I was thinking of my elementary class. My elementary class has 35. This one has 40. So there's 40 questions on your practice one to look at. You have 40 very, very similar questions on your take-home final. So use the practice one to help you do the take-home one. Now, your in-class final, I'm going to cut it down to 30 questions. So of these, I'm going to cut it down to 30. Now, the take-home final, the practice final, and the in-class one have the same type of questions. Only difference is the order and the numbers that are involved. But use the practice one to help you work out the take-home one, and then when you come to class on that May 12th, you'll take your final exam, and you're going to have already seen the same type of questions. So you're going to know exactly what's on them. And the take-home one is going to be graded. It is worth 100 points, so you want to do well on it. Now let's now look at our practice final, and let's see how we work out question 32. And all the questions that have a mark by them are ones we haven't covered, and the ones we're covering today or next week. But all the others, you should be able to do already. So let's look at question 32. So we're going to try and solve this one by elimination. And what we've got is x plus 9y equals a negative 36. And we've got 7x plus 10y equals negative 40. So when I look at this one, which variable do you think would be easier to eliminate? X or y? Can someone tell me? Looks like x is going to be easier, right? Okay, so I want to end up, since this first one is just an x, I want this to be a negative 7x. That way they add down and they cancel. So we're going to take our first equation and we're going to multiply it by negative 7. And so go ahead and distribute that negative 7 through. You could eliminate for y, but you'd have to use a 90. And that's a lot more difficult than working with the 7s. So distributing through, we now have a minus 7x. One negative keeps it negative, minus 63y. And then negative and negative makes it positive. And 7 times your 36 makes it a 252. Down below, we have a 7x plus 10y equals a negative 40. And we can add those together, can't we? And that clears out the x. You want to make sure that you clear out one of the variables, that you eliminate one of the variables. Adding down, those can cancel. And that's going to leave me then with a minus 53y. And we've got 252 minus 40. That comes out to be positive 212. We'll divide by our negative 53. And that leaves me with y equaling now come out to be a nice even number. It should come out to be 4. Okay, y equals that negative 4. And watch your signs there. It's going to be a negative because when you divide, it makes it negative. And what do we need to do next? We take it, and this is called back substitution. Plug it back in and find the other variable. So then we have 7x plus 10 times a negative 4 equals a negative 40. And that's then 7x minus 40 equals minus 40. Add your 40s and they go away. So 7x equals 0. And we can simply look at that and tell then that x equals now what? 0. So what's our answer as an ordered pair? 0, negative 4. So we use substitution, elimination with back substitution. And that would be the answer that I'm looking for. Look at a couple more of these and then we'll take a short break. Come back and we'll begin looking at logarithms and exponentials. And logarithms and exponentials are going to take a bit for us to go through. So we won't be able to finish them all this evening, I don't think, but we'll get at least the exponents done. Okay, this one, we've got 7x plus 9y equals negative 7 and a minus 4x plus 3y equals 4. And we can eliminate either variable because neither one of these are going to be too bad. 7 and 4, that's 28, right? And we could use 28, wouldn't be a problem at all. 9 and 3 would be easier though, because the least common denominator of 9 and 3 would be 9. So what do we need to do? Well, we need to take that second row and we need to multiply it by what? We don't just multiply it by 3. We need to multiply it by a negative 3. That way it'll cancel. So go ahead and distribute that negative 3 through. The top row is going to stay the same. So the top row stays as 7x plus 9y equals a negative 7. So it doesn't change at all. The bottom row, though, when we distribute through, negative and negative makes it a positive 12x there. Negative 3 times 3 makes it a minus 9y. And negative 3 times 4, well, that makes it a negative 12. And now we can add down. And when we add down, the y's go. So adding down, we've got 12 and 7 makes it 19x. And negative 12 and negative 7 makes it a negative 19. Divide by your 19. And x now equals negative 1. And we take it and plug it back in. Doesn't matter where we plug it back into. I'm just going to plug it back into our second equation. You can use either one. Does not matter. So then we have minus 4 times minus 1 plus 3y equals 4. And minus 4 times minus 1, that makes it 4, plus 3y equals that 4. And move that 4 over. 3y equals now 0. So that tells us then that y again equals what? 0. As an ordered pair, what would that be? Yep, negative 1, 0. One more, and this will be the last one before we take a break. And systems are one of those things, they're pretty easy. I like to put several questions on here because on your final, it's nice to have questions like these. They're much easier to solve than some of the others. You know, it's way easier than a quadratic formula question. So you're going to have several of these. They're not difficult. I do know it's new, but it's not going to be that difficult for us to really work through and solve. So let's look at 34, and then we'll take a short break. Oh, let me copy it down right here. That should be minus 7x, yep, minus 6y equals a minus 13. And you got a minus 7x, or sorry, minus 3x plus 3y equals a negative 39. We can eliminate either variable, doesn't matter. I would say 6 and 3 is going to be easier. So let's take our second equation. And are we just going to multiply it by 2 or negative 2? Which one? Well, we don't need a negative, do we? Because this is already negative here. So we can just multiply it by a positive 2. That way the signs are going to be different. So go ahead and distribute that negative 2 through. And that leaves me then with copying the top row, minus 6x, minus 6y, there's a minus 13. And the bottom row is minus 6x plus 6y, and that's what we want. And then we have a, 78, I believe. Negative 78 there. Those can cancel. And minus 7 and minus 6 makes it a minus 13x. 78 and 13, they're both negative, so it stays a negative 91. And we'll go ahead and divide that by a 13. And we'll use a negative 13 here, so watch your signs. And that leaves us then with x equaling now 7. What do? Plug it back in. So plug that back in. And when we plug in that 7, we've got minus 3 times 7 plus 3y equals that minus 39. So that's minus 21 plus 3y equals negative 39. Add your 21 over. And 3y then equals. We've got a 39 that's negative. Positive 21. Those go together to make it then a minus 18. We'll divide by our 3. And that leaves us now with y equaling 6. So what does it look like as an ordered pair? Well, as an ordered pair, it looks like 7, 6, doesn't it? Oh, yep, about lost my sign there. Should be a negative 6, shouldn't it? Just be careful with those signs. If you make a mistake, it's probably something very simple, like a sign error. But again, you'll have 3 or 4 questions on your final that are going to come from these. Maybe 3, maybe 4. I like to use several of them because they're easy. So let's now go ahead and take a short break. We'll come back and we'll begin talking about exponentials. And we'll see if we can get through the exponentials and maybe the logarithms, but I doubt it. So let's try and meet back here in about 10 minutes. So how about we try and meet back here at 7:55.